Section 3, Radical Equations. We're going to start with number 9 and walk through the different types of questions that you will see. Number 9 has one root equal to a number. We will describe this one as having the root all by itself on one side of the equation. When it is in that situation, you are able to undo the square root by doing the opposite operation, which is squaring. But you have to do it to both sides of the equation to stay balanced. The square and the root cancel, and you're left with p, and you have 25 on the other side. Now the problem with solving roots by squaring is that you don't always get an answer that works, which would be called then an extraneous solution. So we must always check our answers. So if we take 25 and put it where p was, and write the equation out, we're wondering, is this true? Root of 25 is 5, would equals 5, and that checks. So 25 works. If we go down to number 11, we notice that the root is not by itself on one side of the equation. So that is our first step. We must get it by itself before we can undo the square root, which gives us a 5 equals root n, which now that it is by itself on one side of the equation, we can undo the root by squaring, and now we have n equals 25 again. But we have to check that. So we go back to the original equation, put the answer we got into where n was, and we solve. Or not solve, but we just check it. So we have 1 equals root of 25 is 5, minus 4. 1 does equal 1, it checks. The next sequence would be to look at number 3, which provides another situation where you have two radicals. Now again, our rule is they have to be by themselves, and in this case both of them are by themselves on each side. So it is technically ready to have the roots undone. So conveniently enough, when we undo the roots by squaring both sides, we now create an equation with no roots. And all we're doing is canceling out the roots and writing down what was inside the roots. So now it becomes a question of solving for x. We're going to undo this division of 4 by multiplying both sides by 4, which means we have to remember that this is a distribution part of the question. So we have 80 minus 4x. If we add 4x to both sides, we get 5x equals 80. Divide both sides by 5, and we get 16. And we have to check that. So we go 16 over 4, which is the left side of the equation, 20 minus 16, and we work out the math. 16 divided by 4 is 4. 20 minus 16 is 4. We root both sides and we get 2 equals 2. This checks. So 16 works. Again, if it did not check, we'd call that an extraneous solution. Our last question we're going to work on is number 15. And this is unique because first of all, we notice that the root is by itself. So we will square both sides. And the result we get is one of our terms being squared. So the rule for solving an equation with a square in it, which means it's quadratic, is that we have to get everything on one side and set it equal to 0. So I will add, well, I'm actually going to do this in a different order here. I'm going to subtract the 9n from both sides, and I'll add 14 to both sides, and now I have a quadratic equation, which we have worked with before and we need to solve by factoring. We're looking for two numbers that have a product of 14 and a sum of negative 9, and that would be 7 and 2, both of which are negative. So we have n, and since this coefficient is 1, we can go right to our factored form with those two numbers, which means we have a 7 as a possible solution and a 2 as a possible solution, which, yes, we do have to check. And if we do so, if I take 7, this is the original equation now, and I plug it in, I get 7 equals root of, and that's going to be 49. So 7 equals 7, and that checks. If I plug a 2 in, that's going to give us a root of 4, and that does become a 2, so that checks. So both numbers work.